Hi, this is really the class notes for, sorry about that, for lesson 6. So lesson 6 is another day of factoring. So we are putting all of these pieces together. If I look at the examples here, at least the first two examples, what I am looking for is looking for a way to factor these examples out. So remember, my the first big step that I'm going to need to take is to find a greatest common factor. Remember, the greatest common factor can be a number and it can also be a variable. So if I start to wrap my head around example 1, is there a common factor? I think that I see that 3 goes into all of those numbers. If I look at example 2, let's see, does 5? 5 may go into all of those. Maybe 3. Oh, does 2 go into 3 and 5? No. So I don't know, maybe I can't factor by finding the greatest common factor for example 3. And then what about example 4? See, 8, 22, and 5. No, because 5 doesn't go into either number. 2 doesn't go into everything because of an odd number. So I don't know, I'm going to have to be a little more creative in example 3 and 4. But let's start with number 1 and 2. So as I said before, I see this and the first thing I think about is let's get that 3 out of there. Let's find a greatest common factor, and that is 3. So remember, always start, kind of like if I'm playing a game and I have to put my piece down, that's where your start place is. That's the GCF. Always start with GCF. If you can. And that can be a number or letter. Remember, a letter is just a variable. Okay. So if I factor something out, it's very important because I saw this on your unit test. If I factor something out, I always draw a line and I divide it by that factor. And then I put that factor outside. Write all your steps out. Don't take any shortcuts. If I factor the 3 out, then I'm going to divide the top terms by 3. And I'm going to rewrite it as a basic trinomial. So 3x squared divided by 3, I'm going to end up with x squared. 9x divided by 3 is 3x. And then 12 divided by 3 is 4. That's going to be a negative sign. So here's my new equation. What we learned about in our last lesson was that, can I factor this basic trinomial? I've already factored out a 3. Can I do the product sum game? Well, I have -4 and I have +3. I'm trying to multiply factors to get to -4 and add them to get to 3. Well, I think that would be 1 and 4. And one of them has to be negative. And it's going to be the 1, because 1 plus -1 plus 4 is 3. That's going to work. Great. Okay, so I'm going to rewrite this now as a binomial by a binomial. So I should have x plus 4 and x minus 1 equals 0. Now remember one of our last lessons that it said, well, now that you have your factors, set them equal to 0. So I have 3 factors. I have 3, I have x plus 4, and I have x minus 1. Those are my 3 factors. Well, is 3 equal? Can I set 3 equal to 0? No, it's not equal to 0, so that's not going to work. Can I set this equal to 0? X plus 4 is 0. And then solve? I can. In this circumstance, x is equal to -4. And then how about this? I can set this final factor to 0. And then if x is equal to 1, then that makes this true. So I'm solving these after I set them to 0. Well, what does this all mean? Well, first of all, is 3a, that's not true. So that's not a factor, that is not true, that has nothing to do with this. Is that we solved, and this is true, we solved that. So basically what this means is that I have two roots or two solutions, and how I would write that is this. X equals the set of -4 and 1. So what this means, again, is if x is -4, then y is 0. That's what we learned up here. If x is 1, y is 0. And that is my solution. Sorry, that is my solution set right here. Okay, let's go on to example 2. Now, remember we said that we could factor this out. I could take a 5 out. So whatever I take out, so here's my GCF is 5. I'm going to stick my 5 outside, and I'm going to divide. So what I should have left over is this divided by 5 is x squared. I should have 4x, -4x, and -12. So that's how I would rewrite this into a basic trinomial. Now I can find my factors. I'm going to use the product sum game. I'm going to get to -12, I'm going to get to -4. And again, you can do the grid method. I know a lot of you like to do that, so just do what works for you. Okay, so I know it's 6. Oh, I think 6 and 2 are going to be my friends. 1 has to be negative, and it has to be the larger number. So -6 plus 2 is -4. That's going to work. So now I'm going to rewrite it. So I should have x minus 6 and x plus 2 equals 0. Now I'm going to set all of the factors to 0. 5, I could set it to 0, but it's not true. One strike, you're out. X minus 6 is 0. Well, then x has to equal 6. X plus 2, 0. X has to equal -2. Now, how do I rewrite this? Well, this is a set. 5 is not a solution. 6 is a solution, and -2 is a solution. So x equals the set of x values that are -2 and 6. Number 3. Oh man. If I can't find a greatest common factor, then I think I should do slide and divide. Can I break this up into 2 factors? I can. So let's go for it. So if I slide and divide, I'm going to rewrite this. X squared plus 3x, 2 times -5 is -10. Remember, I have to tend to this when I'm done. Equals 0. Okay. Product sum game. Okay, I'm going to do it over here. I need to get to -10. I need to get to +3. What 2 numbers will help me out here? Well, maybe 5 and 2. It's one, it has to be negative, but it has to result in a +3. So I think that's a -2. So can I rewrite this now? Yes, my next step is to write this in 2 factors. So x plus 5 and x minus 2. Am I done? Well, you might think, yes, you are, but you're actually not, because remember, we stole that too. I need to give it back. So I need to divide these constants in my factors by 2. So now, is this in simplified form? If I think of this as a fraction, 5/2, yeah, I can't really do much more with it. And I'm not going to turn it into a mixed number or anything. So I'm going to slide back the 2 in front. And then, well, 2 over 2 is just 1. So this turns into x minus 1 equals 0. Now I have 2 factors. Once I have my 2 factors, then I can set them both to 0. So 2x plus 5 equals 0. Well, I am going to subtract 5 from both sides, so I have 2x equals negative 5, and then x is going to be equal to negative 5 over 2. And it's okay if it's a fraction. Keep it like a fraction. Over here, I have x minus 1 equals 0. Well, x should equal 1. So now I have my answer. X is equal to the set of negative 5 halves or 1. So again, what this means is that when x is this, negative 5 halves, y is 0. When x is 1, y is 0. I mean, y is 0. Okay. Last one. And then I'm going to do a different video for the homework. Okay. Greatest common factor? Nope. I'm going to have to slide and divide this one. So slide, divide. Or the Kumon x, or however you do it when you don't have a basic trinomial. You have an a that's kind of big. So I want to get rid of it. So I'm going to slide it over. Rewrite x squared minus 22x plus 40 equals 0. Now let's get it into our two binomials. I have 40, and is it negative or positive? I'm going to make that clear. Positive 40 that I'm multiplying to, subtracting negative 22. Okay. And, oh, I know 2 times 20. It just hit me, right? Is negative 22. And, oh, if you have a negative internal term, they both have to be negative. Sweet. So that's my answer. So x minus 2 and x minus 20 is equal to 0. So set them equal to 0. Oh, wait. You have to do something, right? See, I almost set them both to 0. What did I forget? Hopefully you're at home saying, oh man, Mrs. Botvinnik, you forgot to give back that 8. You stole that 8. You need to give it back. Those constants are not in final form, are they either? Well, if I have x minus 2 over 8, well, that should be equal to x minus 1/4. And then I have, 20 over 8, which is also equal to, well, if I divide by 4, I could simplify this to x minus, well, 20 divided by 4 is 5. 8 divided by 4 is 2. So I now have 2 fractions. So now I'm going to give it back. Once I get in simplified form, I'm going to toss that denominator back in front of my x. 4x minus 1 and 2x minus 5 equals 0. Now I should have given myself more space. But when I solve this, when I set it to 0, x is going to equal 1/4. And that is equal sign, not negative. When I solve this side, 2x, if I set that to 0, because then that's what I'm doing, I'm going to have x is equal to 5 halves. Oh, that's similar to over here. Isn't that interesting? So your answer here is x is equal to the set of 1/4 and 5 halves. By the way, do you think the order matters here? Usually we put the smaller number here, just so you know, but it technically doesn't matter too much because you're just saying it is equal to the set of both of these. Okay. Good luck. The next video, I'm going to do the homework.